Our last section for analyzing data is normal distributions. And we typically can draw a histogram graph, or as you might think of it as a bar graph, to look for normal distributions. And here's what a normal distribution would look like. I would write this down, draw this picture in your notebook, right there. In a normal distribution, we have what we call the bell curve, meaning that normal distribution goes up and down, just like you would to see on a bell curve or like a hill. In a normal distribution, these percentages stay the same all across. So within one standard deviation is 68% of the data, 34% on each side of the mean. Within two standard deviations is 95% of the data. And within three standard deviations is 99.7% of the data from the mean. Again, normal distribution has a bell shape with the center being on the mean. We do have data that could be skewed. It could either be positively skewed or negatively skewed, meaning that more data on a positively skewed graph would show up on the positive end, so the bump lies closer to the left. On negatively skewed, the bump lies closer to the right, meaning more data lies within this region, because this is the chunk of the bell curve that has the most of the data points. But again, we're going to deal with normally distribution. So here's my histogram with my bell curve, and it's telling us that it's normally distributed right there. It says the mean is 115. So right here about would be where the mean is at 115. And approximately what percentage of female brown bears weigh between 100, so if I look at 100 is right here, to 129. So right here, this section, what percentage? Well, since now I know which section I'm looking for, this section in between these two lines, now I can use the percent of bears in each column. So this is roughly about, let's say 23%. This would be roughly about 42%. And then again, this would be 23, because normally distributed means that these two sections are going to be the same. So now I'm just going to add up all of my percentage of bears, so my three columns that I have. And I would get about 88% of female brown bears weighing between 100 and 129 kilograms. For this question, I want you to solve this first one, A, by yourself. So pause and figure out what percentage of females are below 120. So adding up all the percentage below. You should have gotten roughly 71%, because it's everything below 120, so this is about 42%. This one's about 23. Here's 5, and there's just a little one here, so that's 1. So I added up to 71%. Now the second question says, what percent of female brown bears are within 1.5 of the standard deviation of the mean? This isn't my standard deviation, that'd be one standard deviation. So 1.5 standard deviation would be 15 in both ways. So my mean here is going to be 115. So if I subtract 15, that's to 100, because that's 1.5 standard deviation on the left-hand side, and add 15, that's to 130. So now I am looking in between 100, so right here, to 130, about right here, which would actually be the same type of problem that we had on the previous slide. So each one of these would be roughly 23, 42, and 23. So it would still, again, be 88%, because adding up my three columns or bars that I have there. My next problem says the heights of adult American males are approximately normally distributed with a mean of 69.5 and standard deviation of 2.5. Now, before I even get into the problem, I'm first going to draw a bell curve. So I'm going to draw my bell curve right here. Again, with normal distribution, the percentages are always the same. So right here, this is going to be my mean, and I'm going to label that 69.5 because that's given. Now, within 34% on each side, so I'm going to draw two sections on both sides. This is 34% of the data, and this is 34% of the data, is within 1 standard deviation. So if I subtract 2.5 for on the left-hand side, that's going to give me 67 inches. If I add 2.5, that's going to give me 72 inches. Now the next section in a normally distributed curve is going to be 13.5 in between these two sections. And again, that's within another standard deviation. So I have to subtract 2.5 again. So 64.5 and add 2.5 again. So 74.5. And my last section is going to be within 2.35% on both sides. And again, on the left-hand side, I subtract, and so I would get 61.5, and I would add 2.5 on this side, so that would be 77. Excuse me, this would just be 61. So now I look at my question. It says, what percentage of males are in between 67, so here I have a 67, and 74.5 right here. Now in between these three sections, I'm going to add up the numbers that I have. I have a 34, 34, and 13.5. So and once I add those all up, I get 81.5%. So 81.5% of men lie in between 67 and 74.5 inches tall. For this next problem, I want you to solve by yourself using the same curve we just drew for the last problem. So asking what percentage in a group of 2,000 men would be taller, or how many men would actually be taller than 6 feet or 72 inches. So first you're going to have to find the percentage of men that should be greater than 72 inches. Again, pause the video and attempt that part by yourself. This problem could be a little tricky. First, I'm looking for greater than 72, so any number on the right-hand side greater than 72. So I have the 13.5, I have the 2.35, and the very little small end tail is 0.15. Or you could add up these two and just round up, because I still have to include this very small amount of tail. So I got 16%. But it's actually asking how many males in a group of 2,000 would be greater than 72 inches. So 16% of the group, so of you should multiply of 2,000 is what I'm looking for. If you do 0.16 times 2,000, you would get about 320 males would be greater than 6 feet tall. Make sure you took good notes and have that normal distribution curve written in your notebook with the correct percentages, and have a wonderful evening.